So welcome back. In our journey so far, we have learned about the model, which is our trained AI expert. We also talk about the dataset, which is nothing but the study material, and also our helpful toolbox known as utilities. And our chapter 4, we talk about the configuration, which is nothing but the rule book for our tasks. Now that we have a trained model and know how to set rules for what we want to do thanks to this configuration, how do we actually use that model to look at new pictures or videos and get this analysis? This is the job of the predictor. So we'll be talking about the predictor in this chapter 5. So what is the predictor? So imagine you have already trained your AI expert the model to spot cats and dogs. Okay. So now our predictor, which is the part of the authority system that does this work, so it will differentiate between different pictures. It takes the new data like your photos and feeds back them to the trained models, which is a brain, and then takes the raw findings from the model and turns them into something useful and understandable, like drawing boxes around those detected objects. Think of the predictor as the bridge between your trained model and the new data you want to analyze. It is an active engine that orchestrates the process. So first you are loading the new data. So reading images or video frames or even capturing from the streams, for example real-time capturing. So getting the data ready. So preparing the data in the format the model expects, like resizing, changing the pixel values or other. So after getting your data ready, you will run the model by passing the prepared data through the model's neural network, which is the brain. Next the processing will be occurred, the processing the raw results. This is the taking the numerical output from the model and converting it to the detections like bounding box, class names and confidence scores, or even the max key points, and depending on the task. So it is whether it is segmentation or classification or something like that. Later you will be giving you to the findings like providing the results in a structured way. The center way you interact with the predictor in the alternatives is by using the .predictor function. So which is a method of a loaded YOLO model object. So the central way is, as I mentioned, it is by using the .predict function. Now we have one example here. So in this simple line, the results function or results line, this hides lots of work done by the predictor under the hood. It will just basically contains all the findings from the predictions, and we'll explore the results object detail in chapter 8. So now let's talk about the types of predictors. So while there is a foundational base predictor, okay, this is the base predictor is a foundational that handles the general workflow like data loading, running the model. There are other specialized predictors for different tasks, like a detection predictor for the models that find objects and draw the bounding box. And for the segmentation predictor, it is for the models that draw the outlines and the marks around these objects. Another is the classification predictor for the models that categorize the entire image, like a cat or dog. And the pose predictor for the models that find key points on the object and like that. Another is OBB predictor to find the oriented bounding box. We'll be talking about these things in our chapter 8. So these specialized predictors inherit from the base predictor but add the specific logic needed to interpret the raw output of the respective models type, and they will later format the final results. So for example, this detection predictor, it knows how to apply non-maximum suppression or NMS to filter the bounding boxes, while this segmentation predictor, it knows how to generate pixel max from the model's output. So which is a little vast, but will be not covered in this section. So for basic talk, we have one example here where we saw how the configuration in chapter 4. We saw how this configuration and their settings control the task, right? But this predictor heavily use these settings. So for example, when you call model.predict, when you call this model.predict, then you can pass arguments that configure how the prediction is performed. So like you are passing image size, configuration, IOU and others. So this is the model. We load our AI export like YOLO model, and this model predict, we tell the model to perform prediction using these specific settings. These are passed as an arguments, and these arguments will be processed by our configuration system, which is the rule book we talk, and then that will be again passed to the predictor to be used. And here is a source which provide the information about our file or the location of our image or video as per necessary, or even the webcam. And this predictor handles loading data from different sources. So another is, so next is our this different files like config, IOU and image size. So these are the examples of prediction specific configuration, alright. And these parameters control how the predictor processes the model's raw output and prepares the input by setting the non-maximum suppression threshold and showing the detection with confidence limit more than 40% and others, and resizing the images to this more pixels. This show and save, this will tell the predictor whether to display the result or not on the screen, and also to save the annotated output to the file. Whereas stream, it is very important for the videos or the real-time implementation because YOLO is very good at it, and it tells the predictor to yield the results one frame at a time as a generator, which is much more memory efficient than loading everything at once. So this predictor takes this instruction from the configuration and executes the prediction loop efficiently. Now how this will work, let's talk about that. So I have created a basic flowchart here. So when you call the model.predict or model, the YOLO class will act as a high-level interface based on the type of model loaded, like detection or segmentation. The YOLO object internally initialize the correct task-specific predictor like detection predictor or the segmentation predictor. So you can see it here. So when you call the model and the source, it will be calling the task predictor like a detection predictor. So the predictor then takes over. Now the task will be of the predictor. So first it will be initialized. It receives the model, the configuration settings and other things, and the source, okay. And it set up the device like which is whether to use CPU or GPU, and it also loads the model weights on that device. Next there is a data source setup. So for the data source setup, it identifies the type of source. So for example, whether it is video or image or even stream. So or even the stream, and it sets up the appropriate way to read the data from it. And for example, it will utilize the device like CPU or GPU and loads the model weights onto that device. So as we talk about that, so after the data source of the prediction loop, there is a prediction loop. So we can see all the process happening here. So when the after loading the config setup during the devices, the data batch will be read and passed to the data source, which will again return the data batch. And the pre-processed data, which is feeding the data to the model for the thinking for the AI model instance, and which will be returned again as a raw model output. Then the post process will happen. So for example, this after reading the batch of data from the source, then the the data will be pre-processed like resizing, normalizing pixel, or to even match the model's expected input format and size. So like image size, right? And this pre-processed data will be fed into the model. This is where this is where our AI model instance is, where our brain does its work. This is a model. and then the model would return the raw numerical output from the model. The model will return the raw model output, and which will be later passed for the post processing. The post process the raw output using the task specific logic like NMS for detection, generating marks for segmentation, and this is where the specialized predictors and the value predictors add value. So this is where the predictors work, right? And this is where the predictors do its jobs. And then it will create the results by combining the different structure findings. And this again will be handled saving as well as our displaying the results based on this configuration whether. So we have seen that save and the show functions, and this will be repeated for the next batch and the frame until the source is exhausted for all the time until it is moved to the last state. The output will be returned for the results if the stream is true. So this is we talk about the simplified version. So there is also the best predictor as we talk, and there is the detection and the segmentation predictor which will work on the as per necessary, and non-maximum suppression or NMS will be utilized by the detection predictor for the post-processing, and other methods by the segmentation. So these are certain functions like a best predictor, how it works. So there is inference which is like generating the data or result based on the training, and post-processing means converting back to the results that can be easily viewable. And this is for the detection predictor, how it works. Okay, this is just an example, basic example. So I think this is the conclusion. In this chapter we introduced the predictor. This is the essential engine that takes a trained AI model and uses it to analyze the new data. So we saw how it works behind the scenes when we call model.predict or model function, like handling data loading, pre-processing, running the model's inference, and post-processing the results into the meaningful formats like bounding boxes or marks. So this post-process, it works for the bounding boxes or marks, and these are often guided or all time guided by the configuration settings which we talk on the chapter 4. Also, we briefly touched task specific predictors that handle the unique output formats for different AI types. So we talk about how the segmentation we can say for this is for the our detection predictor. This is the best predictor, and the predictor is crucial for applying our trained model to the real world problems. Now that we understand how to make predictions, how do we know how good those predictions are? That is important question. In the next chapter we'll explore the validator, which is used to measure the performance of our model. Thank you.